now move towards the last session of the day, the role of carbon capture, utilization, and storage towards decarbonizing the power plants. And this session is going to be delivered by Ms. Sarbani Ray. Ms. Ray, presently a consultant in energy, has worked for 26 years with NTPC in various positions. As an additional general manager, she has led the operation management of 3 captive power plants, Durgapur 2 by 60 megawatt, Rourkela 3 by 60 megawatt, and Bhilai 2 by 210 megawatt, and project monitoring of emission reducing projects like FGD installation, refurbishment of ESP, and obsolescence projects like DDC MIS. She has worked in the operation and maintenance of power plants and also in corporate operation services, providing expert services to thermal, renewable hydro plants of different capacities across the country. Um, Moderating this session would be Mr. Kaushal Vaishnav. He has multifaceted experience in the energy sector across business development, project management, and regulatory. He is currently working across the energy and infrastructure segments. He has been involved in EPC as well as consulting projects of national and international repute, working largely across state and central board entities. He has also worked with Fortune 500 companies on multiple projects based in Asia, Africa, and the Middle East. While Mr. Kaushal could please set the context for the discussion, requesting Ms. Sarbani Ray to please take her presentation forward. Over to both of you.
Thank you. Thank you so much, Riyal. Hello, everyone. Good afternoon. And I think it is now the time, so I will say better it is good evening. And I welcome you all on behalf of CEE. And thank you so much, Riyal and the CEE team for this opportunity to join you today in this great conference. And I think it is a really learning experience in terms of the education or in terms of the facts which are being shared by the panelists or the presenters. So indeed a great opportunity, and glad to moderate this session. So just to set the tone, I think CCUS has been a very much demand of the time in current days, because we are moving towards decarbonization, and green hydrogen and CCUS, these are the key solutions which are helping us to move through or move towards the greener economy. So this is the basic fact of the nature and the requirement of the session. And now I would like to pass this mic to our presenter today. So over to you, sir. Over to you, ma'am. Thank you.
Yes, Sarbani, welcome.
Yeah.
I have given you the host access. You could share your screen and display your presentation. You could go to the slideshow mode. Yeah, perfect.
It's visible, share?
Yes, it is. It is.
Yeah, thank you. Good afternoon, everyone. It's a nice session so far, and I hope my presentation doesn't make you go into somber because it's been a long day. So my topic today is carbon capture, utilization and storage in power generation. Well, carbon capture, utilization and storage is a vast subject. So today my focus will be in context with the power generation. And this topic, basically, we don't have any first-hand experience as of now in India. I think no one has. So it's like we'll be dealing with the data, information, and the second-hand experiences of the people around the world. And so I think the discussion, this is a very good forum for discussion on this before we, and brainstorming kind of thing, and before we go into it. So where it all started, let us, I think in context of sulfur and desulfurization and all other things in here, always NDC targets of India comes first. So after COP26, after our Glasgow COP, our final revised NDC targets is 50% of total installed capacity from non-fossil fuel. So we are assuring 50% of total installed capacity from non-fossil fuel. That means rest, your 50% will still be from fossil fuel. So we'll need decarbonization. So, and this net zero by 2070 is India's target all over the world after COP26, as I think my predecessors have mentioned, that everywhere it is a net zero declaration has been there. And net zero, part of net zero is the decarbonization. So to keep a clean energy future progress with our rich endowment of coal resources, this is for India, our rich endowment of coal resources, because whenever we talk of India, we have to always think of our coal reserves, and which makes us independent in case of fuel. So what is the situation, present situation? India is the third largest emitter of carbon in the world after US and China. In 2019, emission was 2.6 GTPA, and in 2030, it is expected to cross 4 GTPA. But you see, actually, if you see in totality, our carbon emission is not that great compared to US and China. We are only 7%. And our per capita emission is very low because our population is great, thankfully. But so still, like, it's not like that. People will make logics and arguments that we need not be so alarmed as rest of the world or the developed world. But no, it's not like that, because still in absolute quantity, we are generating a lot of emission, lot more than what our energy situation is. In the carbon, in the electricity, if you consider, our per capita consumption is very low compared to the world's consumption. So this consumption will will go higher because of with our development, the way forward, where we are going from today, it will increase, I mean, in multifold. So where will our emission go at that time? So we are lucky that we are in a already in a positive path. So power sector, if you see this diagram, this power sector, there are the carbon, the carbon sectors are other than power sector, iron, steel, cement, manufacturing industries and everything. They are all like very, in fact, they have been termed as hard to abate sectors. They need decarbonization probably more than power sector in today's world, because they can't do without carbon. And in power sector, we are doing a great thing without coal, without carbon emission in renewable. But anyway, that will come later. So first we see that power sector as of now is the highest emitter, highest contributor of the industrial CO2 emission, that is 51%. So we need to really worry about the power sector. So what is the installation capacity and fuel mix? I'm just giving these details because it is, as of now, my subject is very, theoretical, So the renewable is 30% and thermal is 57% in our fuel mix. This last year, if you see that 22 by June 22, around that record, then renewable was 27%. Share of renewable was 27% and thermal was 60%. So see, we are progressing at a very great rate in case of renewable. But is that enough? Renewable has shown a steady increase from last year's 26% to 30% share in the fuel mix, and in the same manner, percentage share of the thermal has reduced. And India's revised renewable power capacity target is 500 gigawatt by 2030. Still, our 2022 target, if you see that we have done really great on that target, our policies, luckily the cost, the scale, the learning, everything together, the price has come down and India has done a great thing in renewable capacity addition. So energy demand of India would increase as per the IEA latest India outlook. The energy demand of India would increase by 25 to 30% and 60 to 70% in 2040. So that's what I was saying. Like, we are in a very comfortable position now as per our per capita emission, but it will not be like that so for long, because our demand will increase and our electricity share in the energy will increase because we are in a growth path. So even with considerable share of renewable in the fuel mix, coal will require to meet 50%. That is the IEA prediction in all scenarios, that in all good scenarios like steps and sustainable development scenarios, it will be still 50% of the electricity demand will come from coal by 2050. So coal would continue to be the major fuel source for Indian power sector because of this following reasons. If you see the relatively new infrastructure of existing power plants, this is being now discussed for some time by IEA and other major energy agencies, that Asian fleets, India is one amongst them, Asian fleet of power plants is very new compared to the world, rest of the world. And huge domestic coal reserve. We just cannot do without it. We have a huge domestic coal reserve, which makes us independent, energy independent. So we cannot do away with that coal reserve just like that. These are two major reasons. This has been pointed by all our reports and government, even the government's draft reports, that these two reasons why we should keep our coal and why we should go for clean coal. So 210 gigawatt capacity of India's coal-based power has an age less than 15 years. So that's what, that's why we require coal. That's a coal-based plant. We cannot do away with it. So globally, this is the IEA data again. Globally, many coal-fired power plants have a substantial average life of 20-25 years and would require to continue their operation. Even the 10-20 hours is like we are averaging near 15-20. So ours is like we have to keep it. Even the globally, it is like 20-25 years. So it's not only India. Even the emerging Asia, 80% of the existing coal power capacity was built in last 20 years. And even other parts of India, the coal, where coal is more, substantial. So compared to other CO2 intensive sector, okay, now comes the renewable. Where is renewable then? Where does renewable stand? Because power sector has a advantage over other sectors that already it is going through decarbonization. It is going through decarbonization using renewable technology, which is very, which has progressed very well over the years. So renewable energy is predicted to be able to achieve 30% of required decarbonization in power sector. Even in 2050, when renewable power is expected to cross 50% of share in fuel mix, we would require the coal power or fossil fuel power, because for us, natural gas is where other people are doing that with the natural gas, which is a much cleaner option. We cannot do it. We don't have gas. And so we have to do this because the variable nature of the renewable power, we have to do this base load power demand with coal. IPCC working group, the International Climate Panel, that they have already declared the CCS to be one of the CCS wide-scale deployment of CCS as the how we are going to do the decarbonization. And IEA also in their sustainable development scenario has shown that CCUS is in the power plants would deliver 5% of the low carbon electricity. So out of the from the decarbonization, if 20%, 30% decarbonization is done by renewable, 5% decarbonization will surely be done by CCS. That is how they are predicting the net zero by 2070. It's whoever is, whichever country is working out a roadmap for the net zero, CCS is a part of it. In fact, CCS is the oldest technology which is being considered as a major tool for decarbonization. It has been there for around 50 years now, but well, it is being evolving, the technology is evolving only recently. Now, these are the three greatest contribution of CCUS. If you consider how the carbon capture is going to help the power sector, so these three are the coal-based power plants. These three are the greatest contribution of the CCUS in power generation. One is tackling emission from existing power plants. Like existing power plants are considered like they will retrofit with the CCS. So to reduce the carbon. So that way we will get a return on investment, because if we have to retire this young power plant, that is not an option, not a viable option. So tackling emission from the existing power plants, then flexibility for stable power. So again, that coal is offering us, the coal power plant is offering us the flexibility in short term, like in day-to-day peak demand scenario, and in long term, the seasonal peak demand scenario. So flexibility is again CCUS, because they are after retrofitting in the power plants, they are going to help us to remain within the norms, the whatever following the norms, we can keep our power plants, or we can increase the life of the power plants. So now third is net zero and negative emission. So once we achieve the net zero, and then if CCS with bioenergy, it is being predicted that CCS coupled with bioenergy will give us negative emission, and which will help us to counter the emission from the other carbon sectors like cement, chemicals, steel, like that. These are all like very human. Now it is a prediction kind of thing, negative emission. I don't have much information about it. So this is if we consider now carbon capture and utilization, when you talk about the CCS, carbon capture, it is not a carbon capture. It is basically an integrated system where we consider the capture is one part, and the next part is, and then subsequent parts are the storage, then transport, and then the utilization. So carbon capture, when CCS is again, like it is carbon capture storage. Somewhere, some places it is called carbon capture system, where all these things are part of this integrated system. So first we consider the carbon capture, because I'll talk about a bit about the technologies now. And technologies, of course, related to power generation, because there are a lot of options and a lot of things are going on in this field, development of technologies of carbon capture and related system. But if you talk about power plant, then we have in flue gas all these things, all these components of flue gas are CO2, H2O, SOx, NOx, and other gases. So what we do is we separate the carbon separation. There are methods of separation available now. The technologies available now are, one is absorption, which is using the solvents, chemical or physical solvents, to separate CO2 from the other components of the flue gas. And this is if you see, I have like this color is cyan. So this is a norm that the International Energy Agency, they use cyan to mark a mature level of technology. So this is the most mature level of technology as of now of the carbon capture. This absorption technique, absorption with using solvents, chemical, physical. And there are these are all very early kind of prototype or demonstration techniques, adsorption, membranes, and like you use the adsorption method to separate carbon, then you use the membranes, and cryogenic distillation, where you freeze the carbon actually, then frozen carbon is taken out, and then algae-based carbon. So these are but these are very, in the initial, not the initial exactly, but some are still in the lab stage, and some are still in a prototype or early development stage. And there is, of course, the direct air capture, DAC. So this is again very early stage of development, but once developed, it is expected to to be of great help to decarbonize the small sectors of hard to abate sectors, small utilities, small facilities of hard to abate sector. So it's in India, we are doing a lot of things, a lot of research work on direct air capture, because direct air capture is not a developed technology. And so in India, considering our all small facilities, which are very carbon intensive facilities, we are of the opinion that the direct air capture can be a simple method of decarbonization and simple and cost effective method of decarbonization if it is proven, if it is can be established in a commercial scale. So that is another. Next is, there are three main technologies for CO2 capture if you consider the power generation. This one is post combustion, one is pre combustion, and then oxy-fuel combustion. Post combustion, when we capture the CO2 after fuel combustion. So we use the methods in the where we actually use the separation, where we do the separation. Based on that, these are the three divisions. Post combustion captures CO2 after fuel combustion. Then this can be retrofitted to the existing plants, the post combustion. And then it is basically post combustion can be applied to all types of facilities. Then pre combustion is capture of CO2 before fuel combustion. And this is again post combustion, as you see from the same color, it is the most developed technology. And pre-combustion is early development, capture of CO2 before fuel combustion, and less use developed from post-combustion, can only be applied to power plants and limited facilities. So pre-combustion has got, but again, these are very, early days of declaring such things against a technology, because pre-combustion is not developed yet. So something might just come up in a year or 2 years from now, we can see a different pre-combustion. Again, the oxy-fuel combustion, people are very much attracted to the oxy-fuel combustion, which is capture after fuel. Fuel is injected with the near pure oxygen. So we have to have a kind of, air separation unit where pure oxygen is generated, and that oxygen is used for combustion instead of air. So this is a very early stage of development, but it is again like people are doing a very fast work on it, because oxy-fuel combustion has got its own advantages to some, very great advantages. So they are trying on this oxy-fuel combustion, and if proven, so in later stages, maybe we'll be using oxy-fuel combustion only for the power plants, for the new power plants actually. Can be applied to the and other processes. Then this, the advantages and disadvantages. Post-combustion it's a 90% capture, and then pre-combustion is also 90% capture. Oxy-fuel combustion, again, it is 100% capture, and highest degree of purity. And then, even the purity is oxy-fuel and pre-combustion, I'm not sure, but it's not proven yet. So it does not require the fundament. That is the best thing about post-combustion, that you don't need to change your fundamental. You can retrofit easily. That's the main advantage, at least for old coal-based power plant. That is the major advantage. And the disadvantage is, of course, CCS. We need a lot of money for CCS. That is the one, that is because of that thing, that is one thing that CCS has never developed so much. High capital investment, energy penalty is very high in case of post-combustion, because of the regeneration of solvent requires high steam, injection. So energy penalty is almost greater than 30%. Then increase in generation cost. Well, it will increase the cost, because it is taking the steam from either it is taking from the existing facility, or it is building a facility for that, to provide power or steam to the CCS. So it is and then, all are actually high capital investment. So these you can just go. And oxy-fuel combustion, I'll just mention, it is supposed to be good for the NOx also as well. It will give a very low emission of NOx. So that is one advantage, one major advantage of oxy-fuel. So in coal-based power plant, this is actually the IEA released that for coal-based with power generation, as of now, depending on the maturity levels of the technology, most suitable technology is post-combustion chemical absorption. All other technologies are in progress. The chemical absorption technology is in early adoption stage. Rest are all are other prototype or demonstration stage. There is one thing, this whether to use the chemical absorption or the physical absorption, for now these two are developed technology, these two are mature technology, and for these two, it depends on what is your concentration of, what is your field of application, whether you are applying it in the oil and gas or other industries or power plant, and it depends on the concentration of the carbon. What is your concentration of carbon and the partial pressure of carbon? So in our coal-based power plant, in the flue gas, concentration of carbon is very low and partial pressure of carbon is also low. So this makes amine-based chemical absorption a most suited technology for coal-based power plant. So what is your solvent? It depends on the whether you use the chemical solvent or what type of chemical solvent you use. That depends on the concentration of CO2 and partial pressure of CO2. So this is a typical, it's a schematic drawing for the carbon capture in power, based on post-combustion chemical absorption. The flue gas actually, it is basically the reaction of solvent with the CO2 of flue gas. It absorbs the CO2 in flue gas. So that is a exothermic reaction. So it generates a lot of heat. So flue gas needs to be the cooled before sending it to the absorber. So flue gas cooling is done using a heat exchanger, and then this solvent, it absorbs the CO2, and this CO2 rich solvent goes to another separation tower called stripper tower. And this stripper tower is actually, it is again, the steam is the solvent is regenerated with the steam, and this CO2 comes out as a pure gas, and the lean solvent without the CO2, it is pumped again to use to the absorption tower, using a pump, less lean solvent. So, and then this CO2, it depending on the use of CO2, your CO2 is compressed and liquefied and then either stored or transported through pipeline. That all depends. This is just a typical, and actually what happens is there are a lot of solvents already available in a commercial label with various vendors. These are solvents, they are working on solvents, and if you see, this is Mitsubishi solvent, Kansai, KS1TM, then BSF, then Ion Clean Energy solvent is IC. Everybody has got their proprietary solvent now, amine solvent for the chemical absorption. So kind of they're getting ready for the market, solvent industry at least. And there are actually, because the solvent, amine-based solvent, is not only for the carbon, they are using it for the sulfur also, to desulfurize also. Let us see the CCU projects. What is the status? Because as of now, we don't have many projects in world or in the world. In India, of course, none. So in IEA Sustainable Development, CO2 captured and storage capacity is estimated to be 5635 MTPA by 2050 for a net zero emission. So you see, it's a huge amount of CO2 captured and storage capacity. So global CCS status report. This is the one report that comes every year about the CCS status. So you can just anytime you can go through their reports. It's very interesting that almost every day a new CCU project is being declared somewhere in the world. You see, if you see these green figures, United States is ahead of everybody. Then Canada is not doing bad either. Some, the Latin America also is doing good, Brazil, and then China, of course, this side. So what is actually this development, this increase in the CCU report, like every day, as they say, that every day one CCU project is being declared somewhere in the world. So what made this, what happened to, what led to this kind of, drive? So one thing is strengthening of policy network. First thing actually, strengthening of policy framework. Everybody after this, COP, not only COP26, I think before that, much before that, they have started doing the policy framework. US is, if you see US 45Q tax credit, then EU Green Deal, climate policy, they have introduced these policies to kind of which actually favored CCUS. And then concept of hubs and clusters. CCU, again, this very capital intensive projects of CCU, which kind of, impeded the growth of CCU or the consideration that CCU can be commercially, adapted. So this hubs and clusters, this concept once came, that kind of reduced the cost and reduce the unit storage cost through the economy of scale. So what you do is you just like you can imagine the similarity with the solar park, which we achieved through, in India. Through solar park, we achieved a high amount of, capacity addition. So this kind of hubs and clusters, because again, I'll tell that when you are talking of carbon capture, it cannot be, it has to be considered as a whole, that carbon capture has to have a utilization, has to have a, storage or transport if you have a geological storage, because large scale carbon capture can never do without the geological storage. Or the utilization like EOR, enhanced oil recovery. So those, everything clubbed together, and if you do it in a cluster, that will give you many benefits of cost benefits. So that way you can reduce the cost. So these things, these ideas and these technologies, once evolving, like they are of course, helping the way to the CCU, even from 10 years before, we couldn't think of this kind of development of CCU. We almost thought that CCU is totally non-viable option for decarbonization, but now it's growing. So that's the one reason hubs and cluster, already you might be knowing about the Northern Lights in Norway. That's a huge hub. That's so far, it is the biggest hub, Northern Lights hub. And it will, I think, come around. It will be functional or operational from very soon. And then demand of clean hydrogen. Once, like even this hydrogen economy, what we are talking about, the hydrogen and the green hydrogen, blue hydrogen, the hydrogen economy, hydrogen as a future fuel, and people are seeing a prospect of CCU in that hydrogen economy. So if we are using the hydrogen produced, or everything hydrogen produced from renewable is a green hydrogen, and hydrogen produced with the CCS from gasification with CCUS is again considered a green hydrogen option. So, and the hydrogen produced in certain technologies of CCU. So hydrogen market means CCU will be a part of hydrogen value chain. So that is again another thought, that is a thought by the market, that is a thought by experts, that CC carbon capture is going to be a part of hydrogen value chain. So that that if hydrogen is a future fuel, then of course our carbon capture has a market. Now presently we have globally 30 operational facilities. If you see this early development stage, then advanced development, in construction, operation, that's quite a lot. And we have 30 operational facility, 30 operational CCU facility, and their capture capacity is 42.5 MTPA, metric ton per annum. These are few I have listed from the CCS stages. Again, these are few with the facility. There are a lot of facilities even under like development, advanced stage, early stage, and pipeline, all those things. But these are few with power generation. They are in all different fields like oil and gas, cement, chemical, all those things. But here, these are the few worldwide in power generation. First, you see the Boundary Dam 3. Boundary Dam 3, as I'll discuss in detail. Boundary Dam 3 is the first functional commercial scale, power plant with CCS, retrofit with CCS. So then these are this thing. These lists are, I mean, if you are interested, you can just go through the list. So it's I mean, even in the small steps, but the work is being done in other countries across the globe. Presently, where we are, when so many things are going on, then why India can't be left far behind? So where we are presently, carbon in India is captured in small quantity as part of, this has been long been there actually. This in urea production, CCS, use of CCS in urea production has long been there. And this 10 MTPA of pet coke gasification in Reliance India, that is one which is functional CCS, you can say, and then 2 MTPA of coal gasification in JSPL Angul. There are no commercial scale-based CCU projects in India, of course. And that India initial adoption of technology, especially capture technologies, has been carried out by a small number of companies from energy sector. This, if you see, these are all demonstration kind of demonstration, pilot, study, project in power generation. There are a lot of things going on in that respect, but I have again listed only the related to the power generation or the oil and gas energy. So NTPC power one in Vindhyachal, NTPC Vindhyachal is has started a pilot project in 2022. It is supposed to supposed to be completed by next year August 2024 August. It is it uses amine-based solvent in, I think, the Carbon Clean the measures Carbon Clean from UK. They are doing it, and in collaboration with the NTPC R&D research Netra. So this Vindhyachal, they will not only whatever like their, I think the target is 20 tons per day or something like that, 20 tons per day carbon capture, and then there will be they will produce, they will have a hydrogen production plant, which is, I think, maybe 2 or I'm not sure about the capacity. So the hydrogen and the methanol, using the carbon, they will be producing methanol as well. So this is a great project, pilot project. Then BHL has a pilot project using the membrane technology and methanol conversion, but it's not completed, I think. Then ONGC has got this feasibility study on enhanced oil. So this, this is very important, that enhanced oil recovery, CO2 enhanced oil recovery also, like work should be done on that, in that respect also, because CO2 oil recovery will provide the benefits of the carbon capture. It will provide a cost, I mean, tangible benefit of the carbon capture. So oil companies are, of course, I'll go into the letter, because our oil industry, oil ministry, oil and gas petroleum ministry has already started some positive work in that direction. Now, this is the first, because we are talking of the power generation. So let us just see the Boundary Dam 3 project, world's first utility scale operation facility in coal power generation. So story of Boundary Dam project is Boundary Dam project unit 3, unit 1 and 2 were retired already. They have, because it was, I think it started in 1959. So 1 and 2, unit 1 and 2 were already they completed their 50 years. So they were retired before, I think, around 2011 or somewhere around that time. And this unit 3 was about to retire in 2021. It came around in 70, I think. 2020-21, it was about to retire. That time they decided, the SAS Power, they had a, I mean, there was a, requirement for CO2 EOR in nearby Shell oil field, So they decided to go with that. The government, of course, government was instrumental in doing this, helping out this project. So they decided that if they like retire this, just like 1 and 2, if they retire the 3 as well, so they are going to lose a lot of power, and they have to, and that time actually in that period, I think it was conceived in 2009. When 2009 it was conceived, the price of gas was very high. So they were earlier thinking of retiring all these power plants and putting a new power plant in, a gas power plant, NGCC. So, but that time the gas price was very high. So instead they did a cost benefit analysis and feasibility and viability study. And with all the things, they went for a retrofit with a carbon capture, So 3 out of 6 units retired after 50 years. Unit 3 was refurbished with an integrated facility to capture CO2 and SO2. So, and another thing is, that time the Canada government also came out with the tax, their benefit incentives, financial incentives. So Boundary Dam 3 is the only coal-based power station having a CCS facility operational since 2014. You see, it was a 140 megawatt power stations, and after retrofit, it became a 120 megawatt base load electricity. It operates using chemical absorption technology, post-combustion chemical absorption technology for both CO2 and SO2. That is another thing, because they needed a SO2 also. If you go through the Boundary Dams, Boundary Dam 3, they are very transparent. They have all the documents and all the, everything available in a public domain. So if you read about the Boundary Dam power stations, how did they decide on the technology? First thing is they were considering oxy-fuel, but again that oxy-fuel did not develop that well. And in the meantime, like one thing is one reason was because of the that requirement of the CO2 for the oil field of Shell. And another thing was that government was looking for a project, and it is basically called that this is a demonstration, commercial scale based demonstration project for coal power plant. This power plant is a very prototype of all other coal based power plants in India and other parts of the world, where like we can learn from their experiences, and we can think of the if everything other things fall into place. So according to UNFCCC, the Boundary Dam power station is a typical of most coal-fired power station, and generally a typical power plant of any size throughout the world. So this can be a model for going forward with the coal-based power when we go forward. Okay. But as I'll discuss totally at the end, I have kept, if I have time, I'll discuss that. There are a lot of, problems, because Boundary Dam 3 is not the only project of power plant which has retrofitted the coal-fired power plant with a CCS. There is another in US also, Petra Nova, and presently Petra Nova has been suspended. So it's not all very hunky-dory about the power plant CCS retrofit. Now,
Sarbani ji, sorry to interrupt, but I would like to place a request that I think in consideration of the timelines, we would request you to kindly
okay, sure. How much
Thank
time
you.
do I have?
I think next 5 minutes, I think it will be fine.
I'll
and
finish
then,
it. No problem. I'll finish it.
Thank
So
you.
if you see CO2 transport, what are this pipeline is a majority, matured technology, and then there is ship port to port, ship port to offshore. Because the problem in transport is, one thing is you have to compress the CO2, that is one thing. Then there is a problem of hazard, safety, major risk, those have to be considered. So that way these technologies are just evolving, but pipeline is it's a evolved technology, it's quite in use. And CO2 use, if you consider this can be a major use, CO2 EOR, enhanced oil recovery, for the oil fields and oil and gas fields. Then green urea is again, it's a mature technology. And F&B means the building applications. You use the building materials like concrete and all, then methanol, chemical, then synthetic. These are all in the various stages of development. Pipeline transport is one of the oldest mature technology and expected to remain a major technology for CCS. You see, if you capture CCS in one place and then you compress it, liquefy to the stage of liquefaction, and then you transport it through pipeline. Because if you want to transfer a lot of CO2, a high volume of CO2, that's the only option. Then this CO2 storage. Again, CO2 storage, we have this options, enhanced oil recovery, which is a major mature technology, and then saline formation and depleted oil and gas reservoirs. The most critical part of CCS is storage. Developed storages in oil and gas fields are good for permanent storage CO2. Present, what we can do is we can use that CO2 for oil recovery, or we can store where we have that oil, which is oil fields, we have that, the storage for oil and gas fields, which are not used anymore. We just can keep the CO2 there without using. We can just keep the store the oil field there. There are this major CO2 storage option, enhanced oil. This is again a mature technology, and this ACBMR, it's a coal bed methane recovery. It is not it's a very early stage. Storage in deep saline aquifers, storage in basalts. These are all being, they're being explored. So India's potential capacity, if you see, 3.4 gigatons is enhanced oil. That is the mature technology. Rest are what the maximum is deep saline aquifers. So once proven, deep saline aquifers is going to be the technology for the India. This is again, you can see if you want, you can say, I will share the presentation, more than 12,000 billion tons, because the global CCS storage assessment has been done. And that is that says that we have enough amount of storage. But only the problem is that we don't have it in one place. Like they are not uniform. They are all, random. So CCS in absence of direct, I'll come to the last part now, the policy development. CCS projects are capital intensive project, and absence of direct revenue generation requires much of policy intervention. Like we have seen that in renewable also, it needed a policy intervention to pick the momentum. So for CCS also it is like that. Wherever there is a policy advancement, that CCS is doing well. So Canada has an investment tax credit, US has a 45Q tax credit, low carbon fuel standard in California. Some people don't have the direct, some countries, they don't have a direct, CCS policy as such, but they are including the CCS in their climate policy. So if you see the Australia, Japan, and Asia, kind of the Malaysia and Indonesia have a CCS specific regulatory regime, and China has included CCS in its climate finance. So Indian initiative, India does not have a CCS policy, or it has not included the CCS in their climate policy as yet, but the only policy explicitly mentioned CCS from the Ministry of Petroleum and Natural Gas, which mandates all oil fields in India be assessed for potential. And the announcement of India's first national, this is the one thing India has done for towards the CCS advancement in CCS, that 2 national centers of excellence has been set up. The policy path for India can be either carbon credit incentive based policy, which is common in or carbon tax based policy. Carbon credit or incentive based policy is basically what US, Canada, they are adapting, and tax based policies some countries of European Union are using. Niti Aayog in their draft guidelines recommends carbon credit based policy following US Canada path for India, because carbon tax policy will drive away the investment. At least you don't, that kind of thought is working here. This is you can go through, this is boundary dam. People who are interested in power generation, they can see the boundary dam and Petronova details. Basically, both facilities were relying on EOR and captured. The just I'll mention one thing, two very important thing here. One thing is that Boundary Dam had a very good contract with the EOR, with the Shell oil field for supplying the CO2 capture. So that CO2, what you say, the sale of CO2 was ensured, and the rest of the some of the CO2 were being stored in a research project in geological storage. But Petranova, what they did is they had a contract, but they will supply the CO2, but they will get the revenue in the sale of the oil or sale of the oil and gas. So problem is that when there was a slump in oil and gas, oil price, the Petranova, again, it was not anymore viable to run the CCS facility. So kind of this was the reason, because Petranova didn't continue operation, but the Boundary Dam continued the operation. So that again I say that use and storage is very important for installing a CCS in power plants. Only the policy incentive or the environmental norm is not enough, to give it a market, commercial level, to run it in a market scenario, you have to have the users and storage in place. So the but the advantages we have from BD3 or Petranova is that again that cost is coming down with, and they are having a better solvent after the experience also. That way the suppliers and the the vendors are have already gained a lot from these two facilities, with which other power plants, other coal power plants will be going forward. So because these are the problems that was, you can get it in anywhere you can get.
So Sarbani ji, can we please take up the Q&A session now and move ahead?
Just two more slides, sir. This is the, so this is the conclusion. Deployment of CCUS in power generation would need extensive support from policymaker. Complete policy-based guidelines need to be in place in selection of power plants and retrofit with them. Government needs to facilitate development of carbon storage, and in a hub or cluster model. Again, India has to go for hub and cluster model. Not only India, all the other countries, mostly from now, from here, they will be going for hub and cluster model, because that non-uniformity in the storage. And in India, CCUS policy would probably be integrated with the climate policy and emission-related policy within the framework of regulator norms for emission. Thank you.
Thank you so much, Sarbani ji, for the nice presentation. I think you have captured a lot of details of all the operational plans to a lot of key technologies in the CCUS market and segment. So thank you so much for the detailed presentation. And going forward, I think we have one major question that I would ask you from our attendees. So the Ms. Lakshmi is asking that can you please brief on blue carbon sequestration and if it is implemented at a global level?
Sequestration, can you repeat the question? I think sequestration has already been implemented for a long time now.
Yeah, I will
but
repeat
in a pilot projects. I don't know. I don't think commercial scale has yet come up on.
Yeah, so the question is, can you please brief on blue carbon sequestration and if it is implemented at a global level?
Yeah, I'm talking about that only. It is implemented in few places of China, but again, China and US also since long. But I think the commercial level, I don't think it is operational as yet. It is all demonstration and pilot projects.
Right. Another last question is one from Mr. Aneja, that what is the estimated cost of carbon capture and storage unit for a 660 megawatt power plant?
That will depend. That will depend on, as I said, like I think for Boundary Dam 3 in 2014, the carbon capture storage was $800 million, US dollar. And for the Petranova, it was 1,000. A little bit later, I think 2016 around, it was $1,000 million US dollar. But again, as I said, the cost will come down. Cost will come down because the solvent was not that great. Now the better solvents are coming along. And even the, as I said, like I mentioned in my presentation, that Mitsubishi is already saying that Mitsubishi is the vendor for the carbon capture system in Petranova. They did the fittings in the carbon capture in Petranova, and Boundary Dam 3 was done by some company, but they used the shell technology, actually, Castanov's technology. So Mitsubishi already declared that they would, from there, they would do it in a less price, in 30% less. So cost is coming down every day, just like with the economy of scale and the economy of learning, also learning by, cost by learning and cost reduction by learning and cost reduction by scale will take place. So it's very difficult to tell exact price like that. By the time it comes to India, maybe the cost will be a lot less.
Indeed. So thank you so much, Ms. Sarbani, for taking out these questions. And I think these were the two major questions which we had. And in case if any of our attendees are having any questions, they could reach out to Ms. Sarbani or
Exactly,
to CE
absolutely.
team. So with that, I think we are moving ahead to the closure of this session. And thank you so much again to all the attendees for taking out this session. And now over to you, Shreya.
Sir, I'm Subhash Kakkar, sir. Aneja Saab had asked some question. So I have an answer to that. He had asked about the TDS.
Sir, please put your video on and speak is what I would request.
Okay.
Yeah, thank you.
Sir, Mr. Aneja had some question. So I'm giving a reply to that. Actually, there are hydro ejectors in the system. So we have a primary hydro ejector and a secondary hydro ejector. So wastewater is generated after the secondary hydro ejector is in service, and the wastewater about 10 meter cube per hour is sent out from the system, because the TDS of this water is more than 30,000 and the density is about 1,300. So that is why this 10 meter cube is removed from the system and fresh water is added. I think that gives an answer to his question.
Thank you. Thank you. Thank you.
Okay, sir. Thank you.
Thank you. Thank you so much.